pressure override and why it matters. Today we're going to talk about pressure override in a high pressure water system. So to do that, first I'm going to draw a small schematic to represent a system. Typically you'll have a high pressure water pump symbolized there. We'll put a P in there, and it draws water up out of a reservoir. Then it's usually connected to a pressure regulator device. Like that, we'll just draw a square. There'll usually be a pressure gauge on it so you know what pressure you're at. And then after the regulator, usually head off to a pressure gun with a spray nozzle where you're going to spray water out. And then we're going to do one last final line, which would be a bypass line back to the same reservoir. And typically, for example, we're going to run a 10 gallons a minute pump, so I'll put a 10 there to represent the flow in this line, the water coming out of the pump. And then the water that goes up to the trigger gun will usually take most of the water flow. So in this example, we're going to do 9.5 gallons out the nozzle, which would leave us with a half of gallon a minute going down the bypass. When this system is running, you'll build a discharge pressure, and in this case we're going to use 1,000 psi for the pressure. And as the system is running, everything is very well. What can happen though is inside the regulator, what's going on is you'll have a seat in here, a poppet with a spring that's adjustable. And when you adjust this adjustment, what it does is it's closing this poppet against the seat to put a small restriction here so that most of the flow goes out the wand and very little goes down to your bypass. And when this is running, you can tell that this would be a very small area because most of your flow is coming out here. Now the pressure override comes into effect is when I release the trigger gun. What happens then is this flow will go down to 0 because we no longer have any flow out here. This flow stays at 10 all the time. That's the definition of a positive displacement pump. So this flow here will change to 10 gallons per minute. So that's quite a change. And to do that, this opening in the regulator will have to increase. In order to do that, the poppet has to go up against the spring load, which will cause more force on the piston, also raising the pressure. So this pressure then will go up to maybe 1,100 psi. And that's the pressure override. The difference here is pressure override. That's the definition. That's what pressure override is. Now, the reason it's important is if the regulator isn't sized properly, like if we use a 1,000 psi regulator to regulate at 1,000, that's the proper sizing and it's got the right spring stack in it. If I were to take a 3,000 psi rated valve, it's going to have stronger springs in it, and to get the poppet to move that same distance, it's going to take more force. Then your pressure override may go to 1,200 just because you've got stronger springs inside of it. So it's important to keep the right rating on the valve to the system that you're going to run. Now another thing that can happen with pressure override is if we run too much flow out the nozzles. If I go back and keep this at 10, but I run this at 10 and run this at 0, I have now adjusted this so tight that I have no opening to bypass. And once I have no opening to bypass, I'm allowed to continue to adjust my regulator tighter and tighter against the spring, which doesn't do anything while the gun is open. But as soon as the gun does close, this has to go to 0, this has to go to 10, and now if I've adjusted this quite a bit because this was closed off, I could actually see this going not to 1,200 but maybe to 1,500 or higher. And that's why it's important to have a little bit of bypass while you're operating the system so that you don't over adjust your pressure regulator. And that's why it's important to be aware of what pressure override is and what it can do.